One at Piccadilly is actually quite unique in how it was designed. So there is opportunity there to kind of, rather than specifying individual section sizes, you look at kind of performance specifications and say if you have a steel section size that fits that performance, as long as it's not inefficient, that it's appropriate for use. So you're not, you can get a bit of flexibility, which actually, once you build that flexibility into the design, then you actually start looking at a much higher potential reuse percentage. But then the other side of it that happened on Piccadilly is that they actually looked at the available stock that was there in the donor building and looked at how that fit into the new building, and can you actually change the design. So the scheme design changed, the framing and the grid layout actually changed to fit, to match the available steel sections, which actually allowed for a really efficient use of the reused steel.
And just to add to what Tom was saying, that is engineering input at an early stage. And currently, you know, the matching tools, they match based on sometimes inertia. They match based on cross-sectional area, properties. They check what you have chosen against the existing based on mass, and they have parameters, you know, plus minus 20%, etc., to make it efficient. But that is just the starting point. This is where we are right now. In 6 months' time, these tools will be able to match the profile itself against defects, you know, and dents. And the panel before was talking about the engineering input to see if this particular section can fit this purpose, because this piece of damage might not be necessary structurally. Well, the tools that there are right now don't do that, but in the future, definitely, it's so easy.
The allocation is just a starting point. I think it's feeding it back into the design. That's when you start really kind of hammering home these efficiencies. That's good.
I think it's quite interesting though, because it shows how far away from a business as usual structural engineering design using reused steel is. Like, most designers are not taught to think about material properties, or maybe they did the lecture on it, but then they got into practice and, you know, used the standard books.
It's not all about engineers. If people come and ask me, have you got some of this steel, I can sell you the steel that you are asking for if I've got it. And if I've got reused steel, it's going to perform the same unless I inform you otherwise. And that's only one engineering question. That's not umpteen iterations of a building. That's a building that you've designed that's going to work, that I can offer to put reused material into in a manner that isn't going to affect how that works. The other thing is that if the engineers don't all find ways of consuming my stock, I am going to find ways of selling it. So it's not a case that it has to be this, and I'm sure it works for engineering companies to have multiple iterations and for things to take forever, which is what seems to happen. But it could just be the normal design process with a clause that allows you to incorporate used material. And then simply a simple feedback loop, one loop that checks the material that's been input at that stage to make sure it's appropriate for use.
I think we have to sometimes accept that actually sometimes the reuse steel isn't the actual appropriate one. It might have a better use in another building, so we don't want to be forcing it into our designs just because we want to have that tag of this reused steel. If it could be actually have a better potential carbon saving in another use. It's a really important caveat to that, yeah.